Hey guys, welcome to my channel. My name is Lokesh and I work as a lead architect. So we'll continue our book reading series where we are going through LLM Engineering Handbook uh, and we are going to talk about FTI architecture today. And just a disclaimer that we will not be covering all the chapters. This is just to cover chapter one so that we don't get any infringement on the video content that we are making. So with that, let's dive into it. So in the last video in the series, we discussed about the shortcomings of some of the old ML architectures. So now let's look into the solution which the author or the authors are proposing. The solution is based on creating a clear and straightforward mind map that any team or person can follow to compute the features, train the model, and make predictions. Based on these three critical steps that any ML systems require, the pattern is known as the FTI pipeline. So how does this differ from what we presented before? The pattern suggests that any ML system can be boiled down to these three pipelines: feature, training, and inference, similar to DB, business logic, and UI layers from classical software. So this is a good analogy. So mostly if you work in applications, you will have the UI end of the application, then you'll have some hidden business logic where all the logic would be done, and obviously you need data for that, and data would be stored in DB. And some of the logic as a metadata could also be stored in a different DB, but let's not go deeper into it. So yeah, it's basically important to break it down into a microservices kind of an architecture instead of a monolithic architecture. So this is powerful as we can clearly define the scope and influence of each pipeline. Also, it's easier to understand how the three components interact. Ultimately, just we have just three instead of 20 moving parts as suggested in figure 1.4. So as we saw yesterday, this is a daunting image, and it's very difficult to understand it. So that's why they have proposed a simpler architecture. So you have data here. Data would undergo a feature pipeline so that you define features out of it, transform data into features and labels. Tools that could be used here are pandas, polars, spark, dbt, flink, bilewax. So once features and labels are created, you would then store into a feature store. And then you have a training pipeline. Train models with features and labels. The tools that could be used here are PyTorch, TensorFlow, Scikit-learn, XGBoost, JAX. And then there is an inference pipeline which will make predictions in runtime, so it can use the models that are saved in the model registry, and then there could be some features it could use, and it can make predictions. And the tools here could be PyTorch, TensorFlow, the same set of tools that you have while training your pipeline. Before going to details, it is essential to understand that each pipeline is a different component that can run on a different process or hardware. Thus, each pipeline can be written using different technology by a different term or scaled differently. The key idea is that the design is very flexible to the needs of your team. It acts as a mind map for structuring your architecture. That's fair enough. The feature pipeline takes raw data as input, processes it, and outputs the features and labels required by the model for training or inference. Instead of directly passing them to the model, the features and labels are stored inside a feature store. Its responsibility is to store, version, track, and share the features. By saving the features in the feature store, we always have a state of our feature. Thus, we can easily send the features to the training and inference pipelines. As the data is versioned, we can always ensure that the training and inference time features match, thus we avoid the training serving skew problem. So basically, they're saying that whatever feature, which is nothing but your data, the classification of the data or the important characteristics of the data, they get stored inside the feature. And I actually didn't quite get this part. Always ensure the training and inference time features match. So the training pipeline would reuse the feature that is stored in here. And as you try to make predictions in real time, obviously you would need some input data to make predictions on. So basically, what happens is the versioning of because we are versioning the features, we always ensure that you will not have a different set of feature, or in other words, you will not have a different data other than the data that is being used for making predictions. So instead of features, if we just try to relate it with data, I think it will make more sense. And training serving skew problem, we discussed that in the video before, or in the last video. The training pipeline takes the features and labels from the features stored as an input and outputs a trained model or models. The models are stored in a modular registry. Its role is similar to that of feature stores, but this time the model is the first class citizen. Thus, the model registry will store, version, track, and share the model with the inference pipeline. I need to understand what does it mean when they say the model is the first class citizen. So let me put in here, what does the first class citizen mean with respect to below sentences? Okay, let's look it up. The first means that the model is treated as a core component and given equal importance to other elements in the machine learning, just like features are treated as first in feature store. In the past, the focus was primarily on the features, feature engineering, selection of crucial and machine learning. Okay, model registry. Okay, so model registry, the models are considered important. Similar to feature store provides a centralized repository storing the models. Okay. Thus, the model registry will store version. Also, most modern model registry supports a metadata store that allows you to specify essential aspects of how the model was trained. Most important are features, labels, and the versions used to train the model. Thus, we will always know what data the model was trained on. The inference pipeline takes input, the features and labels from the feature store and the trained model. With these two, predictions can be easily made in either batch or real-time mode. As this is a versatile system, it is up to you to decide what you do with your predictions. If it's a batch system, they will probably be stored in DB. If it's a real-time system, the predictions will be served to a client who requested them. Additionally, features, labels, and models are versioned. We can easily upgrade or roll back the deployment of the model. For example, we will always know what that model V1 uses features F1, F2, and F3, and models V2 uses F2, F3, and F4. Thus, we can quickly change the connections between the models and the features. So essentially, this is the same thing that we discussed. It's very important that the data that you trained on which the model was trained on, and the predictions that it could have made during the testing or the training, the data part should actually match. And also, I think the data plays a crucial role. You can use uh, different versions of models, matching the different versions of the data. But I think it's more, it's given more importance to the data because if the data is not up to date, or it's a different data on which the model was trained on, which means it is different features set on which the model was trained on, then it will not be able to make right predictions in either in real time or in batch time or with batch workloads. The benefits of FTI architecture include the most important thing that you must remember about the FTI pipelines is the interface. The feature pipelines takes in data and outputs the feature and labels saved to this feature store. The training pipeline queries the feature stores for features and labels and outputs a model to the model store. Queries the feature store. Okay. The inference pipeline is the features from the feature store in the model. Okay. It doesn't matter how complex your ML system gets, these interfaces will remain the same. Now that we understand better how the pattern works, we want to highlight the main benefit. Another thing is intuitive to use. It is understand each component can be written into its tech stack, so we can quickly adapt them to as there is no transparent interface between the three components. One can be developed by a different team. So these are basically the advantages of a microservice architecture. Every component can be deployed, scaled, and monitored independently. The final thing you must understand about the FTO pattern is that the system doesn't have to contain all three pipelines. Is in most cases it will contain more. For example, a feature pipeline can be composed of a service that computes the feature and then okay, so it can also be further divided. These pipelines can also be further divided into sub pipelines. As logical, thus it is perfectly fine for each to be complex and contain multiple services. What is essential is to stick to the same interface on how the FTI pipelines interact with each other through the feature store. By doing so, each FTI component can evolve differently. However, what is essential is to stick to the same interface on how the FTI pipelines interact with each other. I didn't get the difference. I didn't understood the, or I didn't understand the meaning of same interface. So let me Gemini it. What does same interface mean with respect to below sentences? So let's see what it shows. In the context of the sentence, means that the panel should interact with the feature store in a consistent and standardized way. Think of an interface like a universal adapter. If all of your devices use the same type of plug, you can easily connect them to any outlet. Similarly, if all FTI pipelines use the same interface to interact with the feature store and more, it ensures smooth communication and interoperability. I think I understood. Should be consistent. So what it means is if you are having, different features or you're breaking down features into, some simpler processes, they should be able to connect to each other so that your overall FTI pipeline is able to, do the job. Maybe I understood it, but this would be more clear if you do some, hands-on. Okay, now this completes the FTI architecture, so we will limit our discussion to this. And once again, thank you for tuning in. And if you like this video, consider subscribing. And if you have any suggestions, please put in the comments box below.